right, let's do some more work with inverses. Before we do this page of inverses, let's review the domains that you're supposed to use for inverses. Sine, you are allowed to look in quadrants 1 and 4. Cosine, you're allowed to look in 1 and 2. Tangent, you're allowed to look in 1 and 4. Okay? Yesterday's video explained why. Remember, with sine and tangent, you're allowed to look from 0 up and 0 down. Same thing for tangent, 0 up and 0 down. Okay? Cosine from 0 to pi. So you have to make sure you state your answers negatively for quadrants 4. Okay, what I would really like to do in this video is talk you through these problems, but do lots of pausing, just kind of stop, give you time to think, and maybe write down your guess before I say it, okay, just to see if you're thinking in the right direction. Sine inverse, I'm thinking of an angle. Negative, put your brain in quadrant 4. Where is the sine? Negative radical 3 over 2. Remember, you're supposed to swing down, so I hope you said something like negative pi over 3. If you said 5 pi over 3, you were close, but you didn't say it the right way, and that will not get you credit. There's only one correct answer when we play this game. Arc sine, I'm thinking of an angle where the second value is 1. What angle am I thinking of? Pi over 2. Let's do it again. I'm thinking of an angle. The cosine, the first value is 0. What angle am I thinking of? The answer is pi over 2. Okay? Again, try to think of the answer before I say it. Okay, cosine inverse. You're allowed to look in quadrants 1 and 2. Since it's negative, put your brain in quadrant 2. What angle am I thinking of? 2 pi over 3. Sine is positive. In quadrant 1, the second number, where am I? Pi over 3. Cosine inverse. Since it's negative, put your brain in quadrant 2. Quadrant 2. What angle am I thinking of? 5 pi over 6. Okay. Here's a fun tangent one. Remember, for tangent, we have to do the over 2 trick. That's the sine over cosine. That is not something I recall from unit circles. So let's go ahead and unrationalize this. Before it got rationalized, it was negative 1 over radical 3. And now we will do the over 2 trick. So here's the sine, here's the cosine. Negative tangents, you're supposed to look in quadrant 4. And if you're thinking 11 pi over 6, you're in the right spot, but you're not supposed to say you're not supposed to say 11, you're supposed to say negative pi over 6. Tan inverse. When the tangent is 1, you should definitely be thinking about the pi over 4. But since it's negative, don't look in quadrant 1. Put your brain in quadrant 4. Okay, down here, what angle are you thinking of? Remember, you have to swing down. Negative pi over 4. Arctan. Okay, tan inverse. Let's put this over a 1. And then we will do the over 2 trick. Tangent's actually kind of nice because there's so much information. Here's the sine, here's the cosine. They pretty much give you everything. If the cosine is 1/2 and the sine is positive, radical 3 over 2, you're thinking about angle pi over 3. Okay. This next section seems to have some nested problems. A problem within a problem. So let's do the inside part first. Okay, let's just go forwards. What's tangent of pi over 4? right? It's a 1. Now, I'm thinking of an angle. Let's go backwards. What angle has the sign, the second number, as a 1? You're right, pi over 2. Okay, another nested problem. The inside part is forwards, so simply go to 5 pi over 4 and tell me the sign. Negative radical 2 over 2. Okay, now I have to go backwards, inverse. You're allowed to look in quadrants 1 and 2. Since it's negative, put your brain in quadrant 2. Where is the cosine negative radical 2 over 2? At 3 pi over 4. So when I'm grading your test, I want to see the inside answer as well as the final answer. And you have to write the outside problem until you actually evaluate it. Okay, cosine inverse. Swing down, negative 2 pi over 3, and tell me the cosine. Negative 1/2. Okay, now we've got an inverse problem. Where are you going to look for negative cosines? Quadrant 2. Put your brain in quadrant 2. Cosine is negative 1/2. What angle am I thinking of? 2 pi over 3. Okay. Cosine inverse. First, swing down, negative pi over 6, and tell me the cosine. Radical 3 over 2. Now we have an inverse problem. Where is the cosine positive? Radical 3 over 2. Put your brain in quadrant 1. Good, pi over 6. Okay. Tangent inverse. This is a forwards problem. Just go to the angle 3 pi over 2, go to 270, and tell me the sign. Negative 1. Now inverse. Now we have to say an angle. What angle has negative 1 as the tangent? Tangent lets you look. Let's just go refresh our memory here. You're allowed to look in 1 or 4. Negative tangents are quadrant 4. Okay, so let's put our brain in quadrant 4. We're looking at quadrant 4. Where is the tangent negative 1? And remember, you have to swing up or down for your answer. Negative pi over 4. That is the way you have to say it. 7 pi over 4 is the right place, but that's not the correct answer. Cosine inverse. I'm thinking of an angle. This is kind of tricky. The cosine is pi. What angle has this point? Wait a minute. That's really weird. There's no such thing as a point that's 3 comma something. That's the angle. That's no solution. There are no cosines that have values more than 1. Okay, that was a tricky question. Okay, sine inverse is 2. So we're thinking of something that has a 2 for the sine. That's also no solution. I think we did that one yesterday. All right, now let's not go no solution crazy. Cosecant inverse. Okay, that's kind of hard for me to think about. Maybe what we should do is do a sine inverse. If the cosecant is 2, what's the sine? 1/2. You have to flip it. Oh, this one's easier to think about. Where is the sine 1/2? Pi over 6. Isn't that right? When you go to pi over 6, it's radical 3 over 2 comma 1/2. The sine is a 1/2. The cosecant would be a 2. So if you can't think about the reciprocals, then let's go ahead and flip them and then think about the sines and cosines that way. Okay, cosecant of, okay, first we have to do an inverse. What angle am I thinking of? Where it's radical 3 over 2 comma something. Pi over 6. Okay, now this is a forwards problem. Go to pi over 6. Think about the sine. Think about that second number. Reciprocate that number and tell me what it is. 2 is correct. 2. Okay, we got a couple more here. Cotangent. Let's put radical 3 over 1. Cotangent is not sine over cosine. It's cosine over sine. These numbers are weird. Oh, I know what I have to do. I have to do the over 2 trick. Okay, I'm thinking of an angle where it's radical 3 over 2, comma 1/2. What angle am I thinking of? Pi over 6. Okay, are you still shouting out the answers before I say them? Here's that secant inverse again. Let's go ahead and switch this. Let's say cosine inverse. It'll be easier for my brain to handle. And then what do you do to that fraction? Let's reciprocate it. We'll flip it upside down. Okay, I'm thinking of an angle that has this value for the cosine. You're allowed to look in 1 and 2. Let's look in 2. You're over here somewhere. What angle am I thinking of? 5 pi over 6. Okay, last one. Cosecant of. What angle has -1 for the cosine? -1 comma something. That's going to be pi. Okay, stay at pi. Stay there. Think about the sine. Think about the sine and then reciprocate it, please. I sure hope you said no solution or undefined. Undefined. Okay. Going along with inverses, yesterday I kind of showed you how to solve some problems, so let's do a review of that, but maybe some fancier ones today. So first of all, what you do is you divide both sides by 3, so we're solving. We're going to do some algebra here. Sine inverse of x is pi over 3. Okay, and remember what I said? We're going to consider that backwards. Backwards meaning an inverse equation. Let's go ahead and write this forwards. Let's write it forwards. So let's write a sine problem. Sine of what angle? Pi over 3 equals x. So you have to switch those around. Now, if you just tell me what sine of pi over 3 is, we'll have our answer. Radical 3 over 2. Okay, so this is how we're going to solve some equations. Let's do another one. Let's take both sides, divide by 4. So cosine inverse of x is pi over 4. Oh, that's an inverse equation. That's backwards. Let's go ahead and write that forwards. Let's just write a cosine equation of angle pi over 4. And what is the answer? X equals radical 2 over 2. Excellent. Ooh, doesn't this one look juicy? Okay, we're going to have to rearrange this equation a little bit. Let's move all the tangents to one side. Let's move the tangents to the left-hand side. There's 5 of them here. And if I move those over, that would be -4 of them. Or if you actually want to see the work, let's -4 tan inverse of 2x. Now the reason that I can do this is because they're both tan inverse and they're both of 2x. So they're going to cancel off to the right. And on the left-hand side, I'll have 1 tan inverse of 2x. Now what about these fractions? Let's put the fractions on the right. So let's go ahead and subtract 8 pi over 4. Here I will subtract 8 pi over 4. Oh, thank you for making common denominators for me. Oh, you're welcome. 7 minus 8 is negative pi over 4. So we have an inverse equation. Let's go ahead and write that problem forwards. Let's write tangent of, let's put negative pi over 4 there, and I'll say equals 2x. Okay, now it's forwards. So please swing down pi over 4 and tell me what the tangent is. -1. Okay, equals 2x. We're not done yet. We have to divide both sides by 2, and x is negative 1/2. Okay, let's go ahead and try this one more time. Let's move all the cosines. Since they're both cosine inverse of the same angle, let's move them to the left. There's 4 here, and I'll subtract 2 more. That will make 2 cosine inverse of that angle. Okay, so the angle doesn't get changed, just the coefficient out in front. Let's move negative 2 pi to the right, make a positive 2 pi. Now this is an inverse equation, so let's go ahead and, maybe we'll divide by 2 first. Let's do that. Let's divide by 2 and get that out of there. Divide both sides by 2. Cosine inverse of x over 3 is just a pi. Okay, is there any more baby algebra we can do? So you rearrange as much baby algebra, adding, subtracting, dividing, until you get stuck. Now we'll switch from inverse to regular cosine of pi equals x over 3. So you switch them around. Cosine of pi is negative 1 equals x over 3. We'll just multiply both sides by 3, and x equals negative 3. Okay, so hopefully you're getting better at inverses, and you can state those proper domains, and hopefully you can solve an inverse trig equation.